Good morning, dear students. Welcome to Jatin Academy. Today in this class we will start important questions from chapter 2 of physics, that is work, power and energy. So let's get started. Question 1. Define work. When is work said to be done by a force? Answer. When the force applied on a body makes the body move, then the work is said to be done. It is a scalar quantity. Question 2. How is the work done by a force measured when force is in direction of displacement? Answer. Work done when force is in direction of displacement. W is equal to F times S. Second force is at an angle to the direction of displacement? Answer. Work done when force is at an angle to the direction of displacement. W is equal to Fs cos theta. Question 3. A force F acts on a body and displaces it by a distance s in a direction at an angle theta with the direction of force. Write the expression for the work done by the force. Answer. Work done when force is at an angle theta to the direction of displacement. W is equal to Fs cos theta. What should be the angle between force and displacement so that the work done is zero? Answer. The angle between force and displacement should be 90 degree as cos 90 degree is equal to 0 for 0 work done. Next, when work done is maximum, the angle between force and displacement should be 0 degree as cos 0 degree is equal to 1 for maximum work done. Question 4. A body is acted upon by a force. State two conditions when the work done is 0. Answer. When the work done is 0, the two conditions are: first, when there is no displacement, S is equal to 0, and second, to the direction of force when the displacement is normal. Theta is equal to 90 degree. Question 5. State the condition when the work done by a force is first positive, second negative. Explain with the help of examples. Answer. The work done is positive if the body's displacement is in the direction of force. Therefore, W is equal to F times S. Example: when the coolie raises the load against the force of gravity, then the work done by coolie on the load. Both the displacement and the force exerted by coolie are in upward direction. Second, the work done is negative if the body's displacement is in the direction opposite to the force. Therefore, W is equal to minus F times S. Example: the force of friction between the body and the surface is in a direction opposite to the motion of the body when a body moves on a surface, and hence work done by the force of friction is negative. Question 6. A body is moved in a direction opposite to the direction of force acting on it. State whether the work is done by the force or work is done against the force. Answer. Work is done against the force when a body is moved in a direction opposite to the direction of force acting on it. Question 7. When a body moves in a circular path, how much work is done by the body? Give reason. Answer. No work is done when a body moves in a circular path, since the force on the body is directed towards the center of the circular path. The body is acted upon by the centripetal force, while at all instants the displacement is along the tangent to the circular path, that is normal to the direction of the force. Question 8. A satellite revolves around the Earth in a circular orbit. What is the work done by the satellite? Give reason. Answer. As the force of gravity acting on the satellite is perpendicular to the displacement of the satellite, we get that work done by the force of gravity is 0. Question 9. State whether work is done or not by writing yes or no in the following cases. Case first. A man pushes a wall. Answer. No, work is not done by a man. Case second. A coolie stands with a box on his head for 15 minutes. Answer. No, work is not done by a coolie. Case third. A boy climbs up 20 stairs. Answer. Yes, work is done by a boy climbing up a stairs. Question 10. A coolie, X carrying a load on his head climbs up a slope and another coolie, Y carrying the identical load on his head move the same distance on a frictionless horizontal platform. Who does more work? Explain the reason. Answer. The capacity to do work is energy and the energy spent is equal to the work done. The coolie, X will do more work as the work done by him will involve a change in potential energy, kinetic energy and loss of energy due to friction, whereas the work done by the coolie, Y carrying the load in horizontal frictionless surface does not involve a change in potential energy and work done by the friction is also zero. Question 11. The work done by a fielder when he takes a catch in a cricket match is negative. Explain. Answer. The work done by a fielder is negative when he takes a catch because the force applied by the fielder is in the opposite direction of displacement of the ball. Question 12. Give an example when work done by the force of gravity acting on a body is zero even though the body gets displaced from its initial position. Answer. The displacement is in the horizontal direction when a coolie carries a load walking on a ground while the force of gravity acts vertically downward. Hence, the work done by the force of gravity is zero. Question 13. What are the SI and C.G.S units of work? How are they related? Establish the relationship. Answer. The SI unit of work is joule and C.G.S unit of work is erg. Relation between joule and erg. 1 joule is equal to 1 Newton times 1 meter. But 1 Newton is equal to 10 raised the power 5 dyne and 1 meter is equal to 100 centimeters. Therefore 1 joule is equal to 10 raised the power 5 dyne times 10 raised the power 2 centimeters is equal to 10 raised the power 7 dyne times centimeter is equal to 10 raised the power 7 erg. 1 joule is equal to 10 raised the power 7 erg. Question 14. State and define the SI unit of work. Answer. The SI unit of work is joule. When a force of 1 Newton displaces a body through a distance of 1 meter in its direction, then 1 joule of work is said to be done. Question 15. Express joule in terms of erg. Answer. 1 joule is equal to 1 Newton times 1 meter. But 1 Newton is equal to 10 raised the power 5 dyne and 1 meter is equal to 10 raised the power 2 centimeters. Therefore 1 joule is equal to 10 raised the power 5 dyne times 10 raised the power 2 centimeters is equal to 10 raised the power 7 dyne times centimeter is equal to 10 raised the power 7 erg. 1 joule is equal to 10 raised the power 7 erg. Question 16. A body of mass m falls through a height h. Obtain an expression for the work done by the force of gravity. Answer. Let a body of mass m falls through a height h either vertically or inclined plane. For example, a hill, slope or staircase. The force of gravity on the body is F is equal to mg acting vertically downwards and the vertical displacement in the direction of force is S is equal to h. Therefore the work done by the force of gravity is W is equal to Fs is equal to mgh. Question 17. A boy of mass m climbs up a stairs of vertical height h. What is the work done by the boy against the force of gravity? And what would have been the work done if he uses a lift in climbing the same vertical height? Answer. Let a boy of mass m climb up through a vertical height h either through a staircase or using a lift. F is equal to mg is a force of gravity acting vertically downwards and the vertical displacement in the direction opposite to the force is S is equal to minus h. Therefore the work done by the force of gravity on a boy is W is equal to F into S is equal to minus mgh, or the work W is equal to mgh is done by a boy against the force of gravity. Question 18. Define the term energy and state its SI unit. Answer. The term energy is defined as the energy of a body is its capacity to do work. The SI unit of energy is joule. Question 19. What physical quantity does electron volt measure? How is it related to the SI unit of that quantity? Answer. The energy of atomic particles is measured in electron volt. 1 electron volt is equal to charge on an electron times 1 volt is equal to 1.6 times 10 raised the power minus 19 coulomb times 1 volt is equal to 1.6 times 10 raised the power minus 19 joule. Question 20. Complete the following sentence. 1 joule is equal to dash calorie. Answer. 1 joule is equal to 0.24 calorie. Second. 1 kilowatt-hour is equal to dash joule. Answer. 1 kilowatt-hour is equal to 3.6 times 10 raised the power 6 joule. Question 21. Name the physical quantity which is measured in calorie. How is it related to the SI unit of that quantity? Answer. Heat energy is measured in calorie. 1 calorie is equal to 4.18 joule. Question 22. Define a kilowatt-hour. How is it related to joule? Answer. The energy spent or work done by a source of power 1 kilowatt in 1 hour is known as kilowatt-hour. 1 kilowatt-hour is equal to 3.6 times 10 raised the power 6 joule. Question 23. Define the term power. State its SI unit. Answer. The term power is defined as the rate of doing work. The SI unit of power is the watt. Question 24. State 2 factors on which power spent by a source depends. Explain your answer with examples. Answer. The power spent by a source depends on 2 factors. First, the amount of work done by a source and second, the time taken by the source to do the said work. For example, if a coolie A takes 1 minute to lift a load to the roof of a bus and a coolie B takes 2 minutes to lift a load to the roof of the same bus, the work done by both the coolies remain the same, but the power spent by the coolie A is twice the power spent by the coolie B because coolie A does the work faster than B. Question 25. Differentiate between work and power. Answer. Work. Work done by a force is equal to the product of force and the displacement in the direction of the force. Power. Power of a source is the rate of doing work by it. Work. Work done does not depend on time. Power. Power spent depends on the time in which work is done. Work. SI unit of work is a joule. Power. SI unit of power is watt. Question 27. State and define the SI unit of power. Answer. The SI unit of power is the watt. The power spent is said to be 1 watt if 1 joule of work is done in 1 second. Question 28. Name the physical quantity measured in terms of horsepower. And how is horsepower related to the SI unit of power? Answer. The physical quantity measured in terms of horsepower is power. It is related to the SI unit watt as given below. 1 horsepower is equal to 746 watt. Question 29. Differentiate between watt and watt-hour. Answer. The unit of power is the watt, W, while the unit of work is watt-hour. Since power times time is equal to work or energy. Question 30. Name the quantity which is measured in kilowatt-hour. Second, kilowatt. Third, watt-hour. Fourth, electron volt. Answer. First, energy is measured in kilowatt-hour. Second, power is measured in kilowatt. Third, energy is measured in watt-hour. Fourth, energy is measured in electron volt. Question 31. Is it possible that no transfer of energy takes place even when a force is applied to a body? Answer. Yes, if the body is acted upon by the force normal to the displacement, there is no transfer of energy. The force is normal to the displacement when the body is moving in a circular path and the work done is zero. Hence, there is no transfer of energy. Question 32. What are the two forms of mechanical energy? Answer. Kinetic energy and potential energy are the two forms of mechanical energy. Question 33. Name the form of energy which a wound-up watch spring possesses. Answer. Wound-up watch spring possesses an elastic potential energy. Question 34. Name the type of energy kinetic energy or potential energy possessed in the following cases. First, a moving cricket ball. Answer. Kinetic energy. Second, a compressed spring. Answer. Potential energy. Third, a moving bus. Answer. Kinetic energy. Fourth, a stretched wire. Answer. Potential energy. Fifth, an arrow shot out of a bow. Answer. Kinetic energy. Sixth, a piece of stone placed on the roof. Answer. Potential energy. Question 35. Define the term potential energy of a body. Name its two forms and give one example of each. Answer. Potential energy is defined as the energy possessed by a body at rest due to its position or size, and shape is called the potential energy. Different forms of potential energy are as follows. First, gravitational potential energy, the potential energy possessed by a body due to the force of attraction of the Earth on it, is called its gravitational potential energy. Example, due to its raised height, a stone at a height has gravitational potential energy. Second, elastic potential energy, the potential energy possessed by a body in the deformed state due to change in its size and shape is called the elastic potential energy. Example, due to its compressed state, a compressed spring has elastic potential energy. Question 36. Name the form of energy which a body may possess even when it is not in motion. Give an example to support your answer. Answer. The body possesses potential energy even when it is not in motion. For example, due to its raised position, a stone at a height has the gravitational potential energy. Question 37. What is meant by gravitational potential energy? Derive an expression for it for a body placed at a height above the ground. Answer. Gravitational potential energy is defined as the potential energy possessed by a body due to the force of attraction of the Earth on it, is called its gravitational potential energy. The gravitational potential energy of a body placed at a height above the ground is measured by the work done in lifting it to that height against the force of gravity. Let a body of mass m from the ground be lifted to a height h vertically. The force of gravity, mg, on the body acting vertically downwards must be equal to the least upward force F required to lift the body. The work done W on the body in lifting it to a height h is W is equal to force of gravity, mg, times displacement, h. W is equal to mgh. This work is stored in the body in the form of its gravitational potential energy when it is at a height h. Hence, gravitational potential energy U is equal to mgh. Question 38. Write an expression for the potential energy of a body of mass m placed at a height h above the Earth's surface. State the assumptions made, if any. Answer. The work done on the body in lifting it to a height h is W is equal to force of gravity, mg, times displacement, h. is equal to mgh. Thus, this work is stored in the body in the form of its gravitational potential energy when it is at a height h. Gravitational potential energy U is equal to mgh. Question 39. What do you understand by the term kinetic energy of a body? Answer. Kinetic energy is possessed by a body in motion. So, the energy possessed by a body due to its state of motion is called the kinetic energy. Question 40. State the work, energy theorem. Answer. According to the work theorem, the work done by a force in the same direction on a moving body is equal to the increase in its kinetic energy. Question 41. A light mass and a heavy mass have equal momentum. Which will have more kinetic energy? Answer. Kinetic energy and momentum are related as K is equal to P squared by 2m, where P is momentum and K is kinetic energy. Both masses have the same momentum P. The kinetic energy K is inversely proportional to the mass of the body. Hence, a body of light mass has more kinetic energy because smaller the mass, larger is the kinetic energy. Question 42. Two bodies A and B of masses small m and capital M, where capital M mass is greater than small mass m, have same kinetic energy. Which body will have more momentum? Answer. Kinetic energy is related to momentum and mass as P is equal to under root 2 mk. Since the kinetic energy of both bodies are same, momentum is directly proportional to the square root of mass. Mass of body B is greater than that of body A. Therefore, body B will have more momentum than body A. Question 43. Name the three forms of kinetic energy and give one example of each. Answer. The three forms of kinetic energy are: first, translational kinetic energy. Example, a car moving in a straight path. Second, rotational kinetic energy. Example, a rotational wheel. Third, vibrational kinetic energy. Example, in a solid, the atoms vibrate about their mean positions. Question 44. State the differences between the potential energy and the kinetic energy. Answer. Potential energy. It can change only in the form of kinetic energy. Kinetic energy. It can change into any other form. Potential energy. It does not depend on the speed of the body. Kinetic energy. It depends on the speed of the body. Question 45. Complete the following sentences. First, the kinetic energy of a body is the energy by virtue of its motion. Second, the potential energy of a body is the energy by virtue of its position. Question 46. When an arrow is shot from a bow, it has kinetic energy in it. Explain briefly from where does it get its kinetic energy? Answer. When the string of a bow is pulled, the work done is stored in the deformed state of the bow, which is in the form of its elastic potential energy. When the string is released to shoot an arrow, the potential energy of the bow changes into the kinetic energy of the arrow, which makes to move. Question 47. A ball is placed on a compressed spring. What form of energy does the spring possess? On releasing the spring, the ball flies away. Give a reason. Answer. Due to the compressed state, the compressed spring has elastic potential energy. The potential energy of the spring changes into kinetic energy when it is released, which does work on the ball is placed on it, and changes into kinetic energy of the ball due to which it flies away. Question 48. A pebble is thrown up. It goes to a height and then comes back on the ground. State the different changes in the form of energy during its motion. Answer. When the pebble is thrown upwards, the kinetic energy in it is converted to potential energy. Its kinetic energy is completely converted into potential energy at the top point in its motion. The potential energy is converted into kinetic energy while coming down, and at the bottom, the potential energy is completely converted to kinetic energy. Question 49. In what way does the temperature of water at the bottom of a waterfall differ from the temperature at the top? Explain the reason. Answer. During the fall of water from the height, the potential energy stored in water at a height changes into the kinetic energy. On striking the ground, a part of the kinetic energy of water changes into the heat energy, which increases the temperature of the water. Question 50. Name the form of energy in which potential energy can change. Answer. Kinetic energy. Question 51. Name 6 different forms of energy. Answer. The 6 different forms of energy are: first, solar energy; second, heat energy; third, light energy; fourth, hydro energy; fifth, nuclear energy; sixth, mechanical energy. Question 52. Energy can exist in several forms and may change from one form to another. For each of the following, state the energy changes that occur in: first, the unwinding of a watch spring. Answer. Potential energy of a watch. Second, a loaded truck when started and set in motion. Answer. Chemical energy of diesel or petrol converts into mechanical energy. Third, a car going uphill. Answer. Kinetic energy converts into potential energy. Fourth, photosynthesis in green leaves. Answer. Light energy converts into chemical energy. Fifth, charging of a battery. Answer. Electrical energy converts into chemical energy. Sixth, respiration. Answer. Chemical energy converts into heat energy. Seventh, burning of a matchstick. Answer. Chemical energy converts into heat and light energy. Eighth, explosion of crackers. Answer. Chemical energy converts into heat, light and sound energy. Question 53. State the energy changes in the following cases while in use. First, loudspeaker. Answer. Electrical energy changes into sound energy. Second, a steam engine. Answer. Heat energy changes into mechanical energy. Third, microphone. Answer. Sound energy changes into electrical energy. Fourth, washing machine. Answer. Electrical energy changes into mechanical energy. Fifth, a glowing electric bulb. Answer. Electrical energy changes into light energy. Sixth, burning coal. Answer. Chemical energy changes into heat energy. Seventh, a solar cell. Answer. Light energy changes into electrical energy. Eighth, biogas burner. Answer. Chemical energy changes into heat energy. Ninth, an electric cell in a circuit. Answer. Chemical energy changes into electrical energy. 10th, a petrol engine of a running car. Answer. Chemical energy changes into mechanical energy. 11th, an electric iron. Answer. Electrical energy changes into heat energy. 12th, a ceiling fan. Answer. Electrical energy changes into mechanical energy. 13th, an electromagnet. Answer. Electrical energy changes into magnetic energy. Question 54. Name the process used for producing electricity from nuclear energy. Answer. The process used for producing electricity from nuclear energy is nuclear fission. Question 55. Is it practically possible to convert a form of energy completely into the other useful form? Explain your answer. Answer. No. Because, whenever there is a conversion of energy completely into another useful form, a part of the energy is dissipated in the form of heat which is lost to the surroundings. Question 56. What is degraded energy? Answer. During the transformation of energy from one form to another, a part of energy gets converted to some undesirable form or a part of it is lost to the surroundings due to the friction or radiations which cannot be used for productive purpose. This is known as dissipation of energy or degradation of energy. Question 57. What do you mean by degradation of energy? Explain it by taking one example of your daily life. Answer. During the transformation of energy from one form to another, a part of energy gets converted to some undesirable form or a part of it is lost to the surroundings due to the friction or radiations which cannot be used for productive purpose. This is known as dissipation of energy or degradation of energy. Example, during the glow of light bulb, a major part of the electrical energy utilized is converted to heat energy while some part is converted to useful light energy. Question 58. Complete the following sentence. The conversion of part of energy into an undesirable form is called the degradation of energy. Thank you for taking the time to listen to this content. If you found it valuable, please consider giving it a like and sharing it with others. Also, don't forget to hit the subscribe button on my YouTube channel to stay updated on future content. Your support means a lot to me. Thank you.